Hi everyone, MindFlareRetro back, finally, with a new video. Hello. And this time, it's a little bit different. This is my everyday go-to multimeter, a Bryman BM257S. I purchased this a couple years ago after doing a lot of research because I wanted something that was fully featured, accurate for my purposes, and had legitimate safety features and ratings. Now, I have been very happy with it, although I find that I primarily only use it for measuring voltages and continuity. But this video isn't about that, it's about this. A little something that the good people at Banggood have sent me. So let's open it up and see what we've got. It's a multimeter and oscilloscope? 2-in-1? Joking aside, I did know this was coming to me. A Banggood representative was kind enough to contact me back in September and asked if I would be interested in reviewing a brand new Mustool multimeter with waveform display. And I thought, nah, it's not really my thing. But then I thought, waveform display? That's interesting. So I agreed. I received the item quite quickly from Banggood, about 8 business days. And this is it. This product has been provided to me at no cost from Banggood. Thank you very much, Banggood. And I am free to do my own independent review of it. No strings attached. And I'm not a big fan of tedious unboxings, so I will skip through any boring stuff and get to the guts of it. Opening the box, we're presented with standard leads. We'll look at those later. The multimeter's in a pouch. We'll get to that in a second. And the bottom of the box, we have an instruction booklet in English, so thank you very much for that. The multimeter itself resides in a pouch. Nice pouch, I suppose. Let's take a look. And here it is, the Mustool MT8206 graphical multimeter. First impression, it looks nice, although I am surprised it doesn't come with a protective case cover. Mind you, the case itself does feel quite solid. I don't feel any flexing or hear any creaking of any kind. The function dial does require a moderate amount of force to move between the function settings. Although the detents do feel snappy, it does feel like you could accidentally get the dial stuck between modes. There are 4 rubber extended function buttons across the top that feel quite fine when pressed. The battery compartment is on the back under the tilting bail. The bail itself holds the device at a good viewing angle, but fails to hold the device upright when pressing any of the function buttons. Here's a closer look at the function buttons and dial. I do like that this device has 2 off positions at opposite ends of the dial range. That way you're not tearing through all the different functions when trying to switch it off. This multimeter has 4 lead jacks along the bottom, so you have to be really mindful of what you're measuring and ensuring that you're plugging your leads into the correct jacks. The device is powered by 3 AA batteries, easily accessible under a cover beneath the tilting bail on the back. You'll notice there is a battery installation diagram on the little cover. You do have to install the 2 side batteries first, and then the battery in the middle. Okay, batteries are installed, and before we power it on, let's take a quick look at the leads that this device comes with. And I am hit instantly with the odor of really cheap plastic. It's quite a strong odor, actually. These are most definitely not silicone, and in fact are very hard plastic. Taking a closer look, these leads claim to be rated Cat 3 1000 volts 10 amps. In my opinion, it would be very dangerous to use these probes on anything other than low voltage projects. The cable itself also appears to be made of a very low quality plastic. Not very flexible, and it's got that stink. Anyway, moving along, let's get our leads plugged in and get this thing powered up for some testing. Well, the black lead into the common jack is not the tightest fit, and the red lead doesn't want to go in. Oh, there it goes. Okay, so it's comes out easily, goes in sort of easily. Not the greatest fit all around. All right, let's turn this thing on. Wow. That is a really nice display. Oh, did you see that? I overshot the millifarad detent. This is exactly what I was talking about earlier. Although the dial does lock firmly into a setting mode, there is the possibility of accidentally getting stuck in between when switching, which you can see here. It's quite easy to do. Okay, first let's do the ubiquitous continuity test. We turn the function dial to the ohms diode test setting and press the select button until we get to the little speaker buzzer icon. There it is with an ohms reading. And here we go. It does seem to be latching quite confidently. I think it's probably safe to assume as well that any missed continuity checks are probably due to the poor quality probes. And according to the manual, any resistance under 50 ohms will trigger the buzzer to sound. I think for most electronics hobby use, this is more than suitable. Now let's measure some straight up voltages using this little AD584 precision voltage reference module, outputting 2.5 volts, 5 volts, 7.5 volts, and 10 volts, all to a precision of 4.5 digits. And for comparison, I'm also going to be monitoring the output voltages with a Fluke 45 that I happen to have on my bench, and measuring the 2.5 volt output. We're seeing pretty good comparison between the Fluke and the Mustool. At 5 volts, again, very accurate. At 7.5 volts, we're seeing a bit more variation. And at 10 volts, we're nearly spot on. It's pretty close, looks good. So I would say regular, everyday DC voltage accuracy is quite good. And of course, if you're a regular subscriber to my channel, you know that I love to rescue and repair old Commodore 8-bit computers. So I thought I'd pull an old, untested Commodore 64 power supply off the pile and measure the voltage of the 5 volt line. I've used some alligator clip leads to connect the 5 volt and ground from the DIN plug of the power supply to the multimeter, and I have the meter set at volts DC. And we're going to turn it on and see what kind of output we get. We should be seeing a hair over 5 volts on a power supply not under load, but we're seeing slightly under 4 volts, so this power supply is kaput. I'm going to press the hold button to freeze and save our measurement because I want to bring in my regular digital multimeter and compare measurements. I'm seeing only about a 15 millivolt difference between the Mustool MT8206 and my Bryman. So let's make it more interesting and compare these to the Fluke 45's measurement. So here's a measurement of all 3 meters measuring the Commodore 64 power supply output, and we're seeing really close measurements on all, so I'd be really happy with that. Mustool's doing a good job keeping up with the other ones. Now let's test some common resistors. Just turn the dial to resistance measurement mode and and I have some everyday 10 ohm resistors here. Oh, well, that took a while. The reading is accurate, but it took the meter about 7 or 8 seconds to actually settle on 10 ohms. Now let's try a 3.3 ohm 100 watt resistor. Again, the measurement is pretty much spot on, but it did take it a while to get there. And yes, this thing is wobbly on its kickstand. Can I press a button? Nope. I'm not going to test every function of this multimeter, but there are a few more things I want to try to measure. Let's measure some capacitors. I'm going to press the select button to get to the capacitance measurement function. And I'm going to start off by measuring a 10 microfarad electrolytic capacitor, assuming I can pick it up. Again, a pretty accurate reading, but it took it like 4 seconds to get there, which is not uncommon for some multimeters, but it just seems like this one takes a little extra time to settle on the final measurement. Next, we have a 4.7 microfarad cap. Again, a fairly accurate reading and in spec. And finally, I think I want to test a 100 microfarad electrolytic capacitor. The meter took quite a long time to energize the capacitor and settle on a measurement, so I'm actually doing this twice to see if I get the same results. Tick-tock. There it is. And that took about 15 or 16 seconds to settle on that reading. So quite a bit of time to measure this little juicy fella. I also want to check out the diode testing function, so I have here a standard 1N4148 signal diode. And the Mustool MT8206 is measuring a forward voltage of about 0.59, volts, which I think is a little bit low for this type of diode. Maybe someone can confirm this in the comments. And sadly, I did test LEDs as well, and I wasn't able to get one LED to light up or get a forward voltage reading, so that is really disappointing. Nothing. The next thing I'd like to test is frequency measurement. I'm using the simple waveform generator function of my digital storage oscilloscope. It's outputting a sine wave starting at 1 Hertz. And that's spot on. Now turning it up to 50 Hertz, near spot on again. 3.4 kilohertz, looking good. 50 kilohertz, looking good as well. 100 kilohertz. Here's 900 kilohertz, although you'll notice the scale has changed to megahertz. And here's a 1 megahertz frequency displaying as 0.999 megahertz. However, if I try to go beyond 1 megahertz, the meter chokes and just shows 000, so it cannot measure beyond 1 megahertz. This is curious because the specifications in the manual do indicate a frequency measurement range between 5 Hertz and 5 megahertz. So I'm not sure if that's a typo or a firmware issue. Okay, I am bored of measuring components, so I'm just going to stick the leads into a mains outlet and see what happens. My cable here with an IEC connector is plugged into a power bar with a power switch, and the power bar is plugged into mains. I am located in Canada, so we should be seeing about 125 volts AC and 60 Hertz. The two leads are connected to the correct ports on the digital multimeter, and all I need to do is switch the function dial to volts AC and throw the switch. And there it is, my mains voltage du jour, 125 volts AC. And you might have noticed that beeping sound when I turned on the power. That's the meter warning us that we are currently measuring a high and potentially dangerous voltage. As well, the meter displays a high voltage warning symbol at the top right corner of the display. Both are welcome cautionary safety features. Continuing on with testing, I have switched the function dial over to frequency measurement, and we are seeing exactly 60 Hertz. I've switched back to volts AC, and now we can start looking at some of the more unique features and functions of this meter. Pressing and holding the display function button for 2 seconds enables the waveform display mode. The AC voltage measurement and frequency are displayed on the right-hand side, but on the left we see a graphical representation of those measurements. By using the two middle function buttons, the ones with the up and down arrow markings above them, we can adjust the time base of the graph, allowing a better overall display of the waveform. And in my opinion, one of the really strong features of this multimeter are its storage functions. The MT8206 can store 100 individual measurements plus 10 graphical waveform measurements. Simply press the hold button to freeze and save your measurement, indicated here by an H and a number indicating the storage location of the measurement. Short press the hold button again to return to live measurement mode. To review saved data, just long press the hold button. We are now in the saved data review mode. The memory locations are indexed 0 through 9 for graphs and 0 through 99 for standard measurements. What we're looking at here at storage location 0 is the very first graphical waveform that I saved, and it was just a simple 3.5 volt DC measurement. That's why the graph is indicating just a straight line. It's not a sine wave because it's not AC. And while in review mode, pressing the center function buttons allows you to scroll up and down through your saved data. Similarly, to review your saved non-graphical measurements, long press the display button to exit graphical mode. And like we did before, just long press the hold button for 2 seconds to bring us to the saved data list. This is a feature I really like with this meter. As I mentioned before, it will store 100 individual measurements. Now you only see 3 per screen, but again, simply pressing the up and down arrow buttons allows you to scroll through from 0 to 99. Like so. Unfortunately, there's no provision to access this data on another device like a computer or tablet, but still, I think it's a really handy feature. If you're new to my channel, you know I normally don't do reviews of any kind, let alone digital multimeter reviews, and I am certainly no expert on the inner workings of these devices. But I am going to open it up and take a peek inside, possibly sharing any intermediate knowledge of digital multimeter circuitry, as I understand it from my own hobby learning, as well as learning from others who are much more knowledgeable than I am, mostly from forums and YouTube. So if anyone watching spots something that I didn't mention, or if I've stated something incorrect, please leave comments below. We are all here to learn. With 4 small screws removed, we were able to lift off the back cover and look inside. And right away, the first thing that catches my eye is the absence of replaceable fuses. Anyway, let's take a closer look, starting at the bottom. Looking at the 4 lead connection jacks, I can see straight away that they're just made of cheap bent metal and soldered to the PCB, which is not a quality design and will likely fail over time. I do see some input protection components like this blue mauve here, and I believe the green through-hole component is a PTC. And surprisingly, here's the fuses, both SMD. The one marked with a C is a fast-acting 200 milliamp fuse, and this little guy is your 10 amp fuse. I don't think I'd want to be holding this meter in a situation where this little fuse blows. Looking up around the battery compartment, I do see a few more input protection devices like these MOVs and resistors, but I don't think I'd be very confident at all testing any high voltages or high currents with this multimeter. Now let's take a look at what really makes the MT8206 tick. The brains of the operation is this quad flat pack IC, manufactured by Chinese semiconductor company 𝐶𝑇𝑅 Micro. The model CS7721 IC is an 8-bit microprocessor with 14-bit analog to digital converter. It is an all-in-one processor designed specifically for use in test and measurement devices. And, as is par for the course, the processor is managed by this well-scraped mystery controller. And one final observation, although most of the soldering on the board is quite good, there are several areas that look like they have been manually soldered after the fact, so I'm not sure if these are corrections during quality control checks or modifications after the boards were completed. But again, there are several areas of the board that look like components have been hastily hand soldered and flux residue has not been cleaned from the PCB. So, what do I make of the Mustool MT8206 digital multimeter with graphical waveform display? Well, weighing the pros and cons, I think it's a digital multimeter suitable for hobbyists working with low voltage electronics. I most definitely would not recommend it for making high voltage and especially high amperage measurements, but I have to say some of its unique features did win me over. Let's quickly take a look at the standout pros and cons, and I think we're going to start with the not so good news first. And first and foremost on my cons list is the poor internal safety design when measuring high voltages and high currents. This includes input protection and mediocre leads that would not survive high currents for very long at all. Of course, if you don't believe me, check out Marco Rep's YouTube channel when he runs 9 amps through these exact same leads, turning them into mushy noodles. And on a related design fail note, what's with the SMD fuses? At a $50 US price point, a digital multimeter should be using proper fuses that can be replaced easily. And this might come as a bit of a shocker, but I don't really care for the waveform display feature. To me, it's more of a gimmick than a useful feature. Many of the online descriptions of this meter use the word oscilloscope. I find that misleading. Although the display is oscilloscope-like, it is by no means as useful as a true oscilloscope. With only 20 kHz bandwidth, 128 by 64 pixel LCD display, no triggering or amplitude adjustments, I find the waveform display a decent visual reference at best. And finally, a few small disappointments. I could not successfully test any through-hole LEDs of any color. Anything I threw at this meter would not light up, and the meter would not show any voltage drop. I'm not sure if I was doing something wrong or the MT8206 just isn't up to the task. And the next minor disappointment, the specs state that this meter can accommodate frequency measurements up to 5 MHz. I was only able to get it to measure up to 1 MHz. So again, could be a fault with me, a fault with the meter, or just a typo in the manual. Okay, bad news out of the way. Now let's take a look at the things I really do like about the MT8206. The first thing you notice when you turn it on is how amazing the display is. The reverse LCD display is very clear and bright. I could read it easily from almost any angle under full workbench lights, no problem. Even though the MT8206 is not a true RMS multimeter, all of the voltage, current, resistance, capacitance, and frequency measurements that I took were all quite accurate and well within spec. And I didn't even touch on some of its other functions such as millivolt, milliamp, and millifarad measurement. And it even has a relative measurement mode that displays the difference between the measured value and a reference value and can be used with most functions of the meter. But this meter's best special feature, in my opinion, is its capability to store 100 individual measurements and up to 10 waveform displays. What a super handy feature whether you're at your workbench or in the field. Now, it is too bad that you can't access the saved data from a connected device, but it's still a very useful and rare feature in a multimeter at this price point. So, would I recommend the Mustool MT8206? Well, even though there are less expensive digital multimeters out there, yes, I think I could recommend it to hobbyists that are using it exclusively for low voltage, low current applications. Its useful features outweigh its drawbacks, and I'm sure any electronics enthusiast would be more than happy to have this meter on their electronics workbench. And having said that, it's time for MindFlareRetro's first ever subscriber giveaway. Banggood was kind enough to send me this new multimeter to review, and in turn, I'm going to share this little bit of Banggood-ness and give it away to one lucky subscriber. So, if you would like to participate and possibly win the Mustool MT8206, you need to leave a comment below with the magic word Banggood-ness, and also include a couple of sentences why you want this unique multimeter, and you must be a subscriber to my channel. I'll leave all the details in the description. In the meantime, if you are interested in learning more about the Mustool MT8206 digital multimeter with graphical waveform display, again, check out the description below for a link to this meter on Banggood's website, as well as a 13% off coupon code kindly provided by Banggood if you decide to purchase the meter on your own. Alright, that is it for me. I am out of here. I hope you found this review to be useful. Yes, I do realize this is not my usual content and this was not a retro computer repair video, but please stay tuned for more retro fun and fix-it projects coming soon. I really do have some cool stuff to share. So, as always, thank you for watching, thanks for your time, and I'll see you again soon.